The electronic returnless fuel systems found in modern vehicles are a microprocessor-controlled delivery system. Desired fuel pressure is commanded by the Engine Control Module, or ECM, and transmitted to the Fuel Pump Flow Control Module via a network data message. This type of system functions as an electronic replacement for a traditional mechanical fuel pressure regulator. The Fuel Pump Flow Control Module sends a PWM signal to the fuel pump, so pump speed is changed by varying the duty cycle of this signal. With the change in pump speed comes a change in volume and pressure. A fuel pressure sensor provides the feedback the fuel pump module requires for pressure control. This sensor is located on the fuel feed line forward of the fuel tank and receives a high and low reference from the ECM. A varying voltage is signalled back to the ECM with reference to the fuel line pressure. This voltage is directly proportional to the fuel line pressure. The fuel pump is mounted in the Fuel Tank Module Reservoir Assembly, or MRA. The fuel pump delivers a constant flow of fuel regardless of fuel level or aggressive vehicle manoeuvres. Some benefits of this type of system are lower energy consumption as the fuel pump only delivers as much fuel as the engine requires, less heat is generated in the fuel due to the lower pump speeds, and reduced fuel pump noise. On this system, a fuel pump enable command is sent from the ECM to the fuel pump module before any activation takes place. This command will be active when the ignition is first turned on for a given time, or whenever the engine is running, or the starter is engaged. Some enable drivers are held to ground until commanded active. This helps eliminate spurious voltages that may inadvertently activate the fuel pump control when undesired. The engine operating conditions will always determine the required fuel pump speed. The ECM sends this request on the vehicle's communication network to the fuel pump control module. The fuel pump control module sends a PWM control to a high side driver to activate the fuel pump. Feedback from the low pressure sensor confirms the fuel pump is responding to the ECM's request. The fuel pump control module is supplied with an ignition source, battery feed and a ground circuit. Fuel pump flow performance DTC is set when the control module detects a predetermined difference between the desired fuel pressure and the actual fuel pressure. Using freeze frame data may help reproduce an intermittent fault. If you can't duplicate the DTC, the information in the failure records can help determine the running conditions present when the DTC was recorded. A battery maintainer will ensure a stable voltage for the following checks. Connect a mechanical fuel pressure gauge to the vehicle and compare the value to the scan tool low side pressure data. Check these values against the specifications for the vehicle. They should be the same. Low pressure on both scan tool and mechanical gauge would indicate a fault in the fuel pump control module, control circuit, or the fuel pump itself. Low pressure on the scan tool only would indicate a fault in the pressure sensor or sensor circuit. A fault here would be accompanied by sensor circuit DTCs and should be diagnosed separately. The most accurate way to differentiate between a control module, wiring harness or fuel pump fault is to use an oscilloscope. Using the oscilloscope, back probe the fuel pump high side control terminal and the ground path. Often, a scan tool can be used to command the fuel pump on, or the starter may need to be engaged. Monitor the signal trace. A square wave PWM control should be seen. If the pattern was okay and there was no fuel pressure, then the fuel pump mechanical and hydraulic circuit can be checked for faults. If there is no pattern, move the earth probe to a known ground point. If the trace is now displayed, there will be a fault in the low side circuit. If there is still no trace, then move the scope lead to the module and back probe. Repeat the activation procedure. If the trace is now displayed, there is a fault in the high side circuit between the two connectors. If there was still no pattern displayed, disconnect the control module harness connector and check for corrosion and terminal tension. Check the module for a bent, damaged or corroded fuel pump control pin. No fault is found. We need to confirm supply voltages and grounds to the control module. Using a multimeter set on volts, connect between the battery supply terminal and the ground terminal. Turn the ignition on. If the meter displays substantially lower than battery voltage, or no reading at all, then there is excess resistance, a short, or an open in the battery supply or ground circuit. Move the meter lead from the ground terminal to a known ground point. This will confirm a fault in either the ground or battery supply circuits. If the meter now displays the correct voltage, then there is an open, short to voltage, or excess resistance on the ground circuit. To rule out a short to voltage, move the other meter lead to the ground terminal in the module harness connector. If the meter displays any voltage now, there is a short to voltage in the circuit. If there is no meter reading, then the fault will be an open or excess resistance in the circuit. With the short to voltage ruled out, connect the meter leads between the battery supply terminal and the ground terminal in the harness connector. A meter reading of 0 or substantially lower than battery voltage indicates an open or excess resistance in the circuit. Move the ground lead to the chassis ground point while watching the meter. If the meter now displays voltage, remove the ground harness from the chassis and clean with a wire brush. Corrosion or paint on these points will cause a substantial voltage drop. Reattach the harness and move the meter lead back to the ground terminal in the module harness connector. If the meter now displays battery voltage, then the open or resistance fault was in the chassis ground point. If the meter still displays 0 or substantially lower than battery voltage, the open or excess resistance is in the harness. An open, short or excess resistance in either the battery or ignition supply circuits will result in no PWM output to the fuel pump. This control module uses 2 fused voltage supplies. If either fuse is open, the control module will not function. An open fuse will be caused by excess current flow in the circuit. A short to ground may cause this. With the fuse removed, connect a multimeter set on volts across the terminals. Disconnect the fuel pump control module and turn the ignition on. Any voltage displayed indicates a short to ground in the harness. No voltage may indicate a fault in the fuel pump, the control module, or a short to another circuit from the module. This could be confirmed by checking for continuity between this circuit and all other circuits connected to the module. If there is no continuity during this test, then measure the resistance of the fuel pump and compare to the manufacturer's specifications. If the fuel pump's within specifications, then the module's at fault. If the fuse is okay and there are no shorts in the circuit, turn the ignition on and check for ignition and battery voltage at the control module by connecting between each supply in turn and the ground terminal. Remember, at this point, we have already proved the ground circuit is okay. If either circuit has a substantially lower than expected value, or the meter reads 0, remove the fuse for the affected circuit and move the meter lead to the fuse supply terminal. If the meter displays the correct voltage here, check the fuse terminals for corrosion and terminal tension. If no fault is found, the open or excess resistance is in the harness between the fuse box and the control module. If no voltage or incorrect voltage was found at the fuse supply terminal, the open or excess resistance may be in the supply to the fuse box. Now that we've proved the power and ground circuits are okay, we need to check the fuel pump enable command from the ECM. With the fuel pump control module disconnected, locate the fuel pump enable terminal in the harness connector. Insert 1 meter probe here and connect the other to the ground terminal. Turn the ignition on while watching the meter. You should see ignition voltage for a few seconds. If there is still a low or no voltage reading, then there may be an open, short, or excess resistance in the circuit. Back probe the enable terminal at the ECM connector with 1 metre lead and attach to the battery negative or a known ground point with the other. Turn the ignition on or engage the starter. If ignition voltage is now seen, there is an open or excess resistance in the enable circuit between the two connectors. If there is still no display on the meter, turn the ignition off and disconnect the ECM. Inspect the harness connector enable terminal and the corresponding ECM pin for damage, tension and corrosion. If none of these conditions are seen, connect 1 metre lead to battery positive and the other to the enable terminal in the harness connector. If the meter displays any reading other than 0, there is a short to ground or a short between another circuit from the ECM and the enable circuit. Perform a continuity check between the enable circuit terminal and all other terminals in the ECM harness connector. If no fault is found, further diagnosis of the ECM supply and grounds will be required. If all grounds, voltage supply and enable circuits are okay and there is no PWM control, then the only possible fault will be the fuel pump control module. Be aware that faults in the voltage supply, ground and enable circuits for the fuel pump control module will log communication DTCs as well. Vehicle fuel supply systems are not as simple as they used to be. Stay ahead of the game with continuous training. Thanks for watching.